What if one of the most dangerous thunderstorms on Earth doesn't begin with a weather system at all, but with a wildfire? That's exactly what NASA is trying to understand right now, using a Cold War-era aircraft originally designed to spy on America's greatest rival. And this time, the target isn't an enemy nation. It's a towering wall of fire, smoke, lightning, and wind. NASA's ER-2 is a modified version of the legendary U-2 spy plane, the aircraft famously nicknamed the Dragon Lady. But instead of cameras designed for intelligence missions, this version carries a flying laboratory packed with scientific instruments. And at roughly 65,000 to 70,000 feet, it's giving researchers a perspective that's almost impossible to get from the ground. The mission is called INSPYRE, short for the Injected Smoke and PYRocumulonimbus experiment. Its goal is to understand one of wildfire science's biggest mysteries: why some fires suddenly create enormous thunderstorms known as pyrocumulonimbus, or pyroCb, and what happens after those storms explode upward into the atmosphere. NASA says the campaign is designed to study the physical connection between these storms and extreme wildfire behavior. Here's what makes these storms so unusual. An ordinary thunderstorm is driven largely by atmospheric conditions. A pyroCb storm can be powered by the heat of a massive wildfire itself. The intense fire sends hot air and smoke racing upward, creating a towering plume that can develop into a thunderstorm. That storm can produce lightning, violent winds, fire whirls, and huge amounts of smoke that reach extraordinary altitudes. And once that smoke gets high enough, the problem doesn't necessarily stay near the fire. Researchers say smoke injected into the upper atmosphere can be carried thousands of miles downwind, potentially affecting aviation, visibility, atmospheric conditions, and weather forecasting far from the original wildfire. NRL says current operational forecast models don't fully account for pyroCb smoke injection, creating a significant forecasting gap. That's where the ER-2 becomes so important. Think of it as a steerable satellite that can fly above the storm and repeatedly pass over an active wildfire. Its instruments can measure the size and altitude of the plume, atmospheric motion, lightning-related electric fields, and other characteristics that help scientists understand exactly how these fire-generated storms develop. But NASA isn't relying on just one aircraft. A Gulfstream V operated by the National Center for Atmospheric Research is also part of the 2026 campaign, collecting measurements directly inside pyroCb clouds. The idea is to combine what the high-altitude ER-2 sees from above with what the Gulfstream measures from inside the storm. Together, those observations can give researchers a much more complete picture of what's happening inside these massive fire clouds. And this isn't just a theoretical exercise. NASA's INSPYRE campaign launched its 2026 science operations in July, with the ER-2 operating from Great Falls, Montana. NASA's mission records show flights and fire overpasses in late July, including observations of fires in northern Oregon, while the broader campaign is scheduled to continue through September 20. NASA currently lists the mission as ongoing. The bigger goal is prediction. Scientists want to figure out what combination of fire intensity, atmospheric conditions, moisture, wind, and other factors causes a wildfire to make the dangerous transition from a normal smoke plume into a powerful pyroCb storm. If researchers can identify those warning signs, future forecasting tools could potentially give firefighters and communities more advance notice when a fire is about to behave in an entirely different way. And there's an incredible piece of history behind the aircraft making all of this possible. The original U-2 was developed during the 1950s, when the United States desperately wanted intelligence about the Soviet Union. Satellites weren't yet available for this kind of mission, so the answer was an aircraft capable of flying extraordinarily high. That aircraft became the U-2 Dragon Lady. Its history wasn't without danger. On May 1, 1960, U.S. pilot Francis Gary Powers was shot down while flying a U-2 over the Soviet Union, exposing just how vulnerable even high-altitude reconnaissance aircraft could be. Yet the U-2 survived the Cold War and continued serving in intelligence roles for decades. Now, that same basic aircraft lineage has been transformed into something remarkably different. Instead of looking behind the Iron Curtain, NASA's ER-2 is looking into one of nature's most violent experiments. It's carrying scientists toward storms created by fire itself. And that's perhaps the most surprising part of this story. A plane born in the Cold War is now helping scientists understand a modern wildfire threat that doesn't respect borders. The hope is that by learning how these fire-breathing clouds form, scientists can eventually make them less unpredictable, and give people on the ground a better chance of knowing what comes next. If you found this update helpful, don't forget to like the video, subscribe to Prime Wire, and turn on notifications so you never miss the latest news. Thanks for watching.